Have you ever wondered how this works? You see, this lava lamp, it's in continual motion. The fluid within here, you can see it is doing strange things. It's actually made of two fluids. There's water in here and then there's a kind of wax. And they have very, very similar densities to each other. And what happens is the wax is getting really close to a heat source at the bottom. A light bulb underneath this metal bit, and you'll feel the thermal energy if you accidentally touch it, is heating the part of the water and the wax at the bottom. And what's happening is, it is making that bit get hot, where it then, as being slightly hotter than the material around it, starts to rise. As it starts to rise, it goes to the top, cools down, and then starts to fall back to restart the process. What is the science behind this? It's possible to see a convection current in some water. Now what I've got here is a heater, and the heater is going to be going into this large beaker. What I'm going to do is I'm going to pour in some boiling water. Now I could put in cold water and have it heat up, but it'll take too long. So I'm going to put in the boiling water, like this, and then we're going to watch what happens. Some more when it is heated. So we'll try and get that to not completely lie down, but almost lie down. And what I'm going to do is I'm going to observe it with this thermal imaging camera. Now, the glass itself here absorbs infrared, so you won't be able to see through the side, but we will be able to look down on top and see what's going on. So, let's flick it on and allow it to start heating up. So looking down into the water, this is before the heater is doing very much, and you can see swirling patterns as the water is mixing, probably the result of when I poured the water in. It's still moving around. In a second or two, we shall start to see the effect of the heating element. So now, a few minutes later, what you can see is that the water surrounding the heating element is getting hot. It is expanding, becoming less dense and floating towards the surface, and here we can see it arriving. The white colours indicate the hotter material. And what does it do when it hits the top? Well, it starts to give off that thermal energy that it has into the environment. At that point, it starts to cool down, and as it cools down, it goes redder until eventually becoming as cool as the fluid around it, and it will eventually start to sink towards the edges, and you can actually see the hot material coming to the surface and then being pushed towards the sides, where it then descends back down again. Now this is another classic example of convection. What I have here is a large ring-shaped test tube, and it's full of cold water. What I'm going to do is I'm going to light this little candle under one corner of it and see what it does to the flowing liquid. Now unfortunately the infrared camera can't see through the glass, and so if I want to see what the fluid is doing, I'm going to have to dye it. What I have here is some potassium permanganate. It is a dye, and I'm going to put a tiny little sprinkling of it just here, and we're going to watch what happens to that as one corner of this is heated. So wasn't that just incredible? What happened was the potassium permanganate was up here and the flame was heating the water here. And of course, by heating up the water, it was causing the water to get hot. And as it got hot, it expanded, it became less dense, and then floated up this like a chimney. And the water coming up here pushed the water everywhere. And the water pushed past the dye, carrying the dye around the chamber. So you can see it's still doing, you can see it coming down here before it's getting reheated and going up. This is a convection current. So this is an oldie, but it's a goodie. Turn that on. What I have here is a little box, and there's a candle just underneath this chimney here. And there are two chimneys in this box. There's one here, and there's one here. And what I'm going to do is I'm going to light the candle. And I'm going to shut the door. Now, of course, what's going to happen here is this candle is going to heat the air. The air is going to become hot. And in becoming hot, it's getting less dense because it's expanded. And being less dense than the air around it means it's going to try to float. Which means that the hot air around this candle is going to try to float straight out of this chimney. But in doing so, it's going to draw air through this chamber from where? From this chimney. In fact, what we should find is for hot air to come out of this chimney, cold air must get sucked down this one. Now there's two ways in which we could perhaps observe this. The first is by using smoke to demonstrate what is going on. So what I do, I'm going to light this because this will make lots of smoke. Okay. And now look, hopefully, now you can see smoke being sucked down. Did you see it? And then eventually the smoke should then come back out of this side. It's quite subtle. It's a subtle experiment. I wonder. There we go, the smoke is sucked down from this match. But I think a better thing to do would be to actually look at the chimneys of the thermal imaging camera. And what you can see, and we'll have to zoom in for this, is that one of these chimneys is red hot at the top, and you can actually see the hot air coming out of the top of it, and one of these chimneys is completely cold. And so it's a demonstration that a convection current is occurring. There are three heat transfer mechanisms. These are basically ways in which thermal energy can move from one place to another place. We've already looked at one, and that is conduction. Thermal conduction of heat from one place to another through a solid normally. Remember, things that are good conductors tend to have atoms in regular arrangements and free electrons. But not all things have atoms in those arrangements, and not everything has free electrons. Some substances, the atoms can't even stay still. And we call those substances fluids. And the heat transfer mechanisms through fluid take advantage of the fact that the substance can move. Convection is the name of the heat transfer mechanism which works for fluids. Convection. The other heat transfer mechanism is radiation, and we'll talk about that at another stage. So convection then, it works for fluids, which include liquid and gas and plasma in the case of the surface of the sun, but you don't need to know that. So how does it work? Well, here's the key thing: fluids can move. Here's the second key thing: things that have a lower density will float. They are the two key ideas. So imagine for now that we have a saucepan or whatever, and it is being heated at some place. Now what I'm going to do is I'm going to imagine this is a saucepan, and I'm going to imagine that heat is being applied to only one place on this whole saucepan. The heat is going to be applied just here, a source of thermal energy on this corner. The surface of the fluid is just here, so there's liquid inside this saucepan. And what's going to happen is I'm going to heat it at this corner. Now what I need you to imagine is that the water here is going to start to get hot. A small amount of conduction makes it hot through the saucepan itself. But in getting hot, the fluid, firstly, it gets hot, its temperature increases. And when its temperature increases, it expands. Like all objects do when they get hot, those molecules of water gain a little bit more kinetic energy. They collide with each other a little bit harder, pushing away from each other, and those molecules start to try to occupy a larger space. That means there's fewer of them now per unit volume. The density decreases. So that means that it becomes less dense. And what do we know about things that are less dense? Well, they float, don't they? And so what happens is the less dense hot water starts to float straight up. They are buoyant. Why is it really moving up? Well, really gravity is trying to pull the cold water down, and the hot water is just trying to float above it. It reaches the top, and at this stage, some of that heat energy can be given off from another form, radiation. And so it starts to lose the energy to the environment. And as it moves across the top, it cools down, and it's cooling down all the time, and then it hits the opposite wall. And what does it do? We can't go up, because that would be leaving the surface of the water. So it's got a dilemma. It's hit an immovable barrier, more water's piling into it from behind, but because it has lost some of its thermal energy, then what is starting to happen to it is the gas gets cooler. And not only does it get cooler, it starts to contract. It starts to fill a smaller volume. Those molecules don't have as much kinetic energy anymore. They don't collide with each other nearly so fast. And so they don't push against each other nearly so much. And so the spaces between the molecules decreases, and the whole gas tries to occupy a smaller volume, which means that the density goes down. The density starts to, sorry, I said down, didn't I? The density increases because it is now occupying a smaller volume. So the density increases, which means it sinks. And so down goes the cool water, down to the bottom, and then along, back over here again, to be heated up again by getting close to the heat source. And so this circle is called a convection current. It explains lots of things. Hot air balloons. They float because they're full of hot air. Like here, they're basically a captured bit of a convection cell. But also the heat in your room. If you have a heater in one corner of the room, it will make hot air rise towards the ceiling, across the top of the ceiling, and cold air will be coming down from the roof on the opposite side. It's worth bearing that in mind when you're positioning a settee somewhere. Also, choice of bunk bed. Why is the top bunk always the best? It's always the warmest at the top and the coolest at the bottom. Hot air rises, that's why smoke goes up, why volcanic ash clouds go and cause problems with aircraft. Have you ever thought about what to do if it's too disgustingly hot in your house in summer? You have two choices. Well, one of the things is go sleep as far down in your house as you can manage. So if you have a kitchen floor, for example, go sleep down there, it'll be lovely. Another thing you can do is open up a path for the hot air to get higher in your house. So maybe open the loft hatch and let all the hot air rise into the loft hatch. You've just got to watch out for spiders. Convection is the heat transfer mechanism that occurs in fluids, not just water, but also in air. It is also the mechanism by which the heat goes from the inside of the sun to the surface of the sun. And so when we saw the pan of water boiling, well, that's exactly the same as what we see happening on the surface of the sun. And it's why we get the energy down here. But the really good question is, if it takes convection to get the energy from the inside of the sun to the surface, how does it get through the space from the surface to us down here on Earth? Well, that's for our next video.